Hi guys, this is Dr. G here, and in this particular video we will talk about naming aromatic compounds. So by this stage you should be familiar with naming organic compounds using IUPAC nomenclature, but when naming aromatic compounds according to IUPAC rules, it could be a little bit challenging, primarily because when it comes to aromatic compounds, IUPAC actually allows a lot of non-systematic names to be used when naming these aromatic compounds. So in this slide, I have a few non-systematic names that are used when naming aromatic compounds. So primarily, if you have a methyl group directly attached to a benzene, that compound is known as toluene. So you should remember these names, okay? Because when you are naming these compounds, you have to remember the term toluene, okay? And if you have a alcohol group or an OH group directly attached to benzene, those compounds are known as phenols. And if you have an amine group directly attached to benzene, the non-systematic name that we use for those type of aromatic compounds is called aniline. And then if you have an acetyl group, acetyl group directly attached to benzene, we call them acetophenone. Okay, acetophenone. And if you also have an aldehyde group, a formaldehyde group directly attached to benzene, we call them benzaldehyde. If you have a carboxylic acid group directly attached, we call them benzoic acid. And also if you have two methyl groups attached to benzene and let's say it is next to each other, we call them orthosilane. So these are some of the commonly used non-systematic names that we will use in naming aromatic compounds. So I would recommend that you guys at least remember the first 6 names because they are very common in aromatic compounds. They are very common in naming aromatic compounds. So if you have any substituents that were not listed in that table, okay, they might have systematic names. They could have systematic names that is associated with the term benzene because you have a 6-carbon benzene ring in these aromatic compounds. So if you have a bromine group attached to benzene, that the name will be bromobenzene. If you have a nitro group or NO2 group, that will be nitrobenzene. And if you have an alkyl group attached to benzene, that will be the name of that alkyl group followed by benzene. The name of that alkyl group followed by benzene. So if you have a ethyl group, if you have an ethyl group attached to benzene, it will be ethyl benzene. Okay, it will be ethyl benzene. But please remember, if you have a methyl group, that is different. Okay, if you only have a methyl group, that will be toluene. Because it is a non-systematic compound name. Okay, all right. So let's talk about the phenyl group up until now, all those names that we discussed, the systematic names or the non-systematic names for benzenes, those compounds primarily had the benzene as your functional group, primary compound. But sometimes you could have alkane branches attached to benzenes. Okay, benzene has only 6 carbons, so benzene has 6 carbons. So if you have an alkyl group with more than 6 carbons, then the primary group will be the alkyl group. The primary organic group will be the alkyl group. So benzene will become the substituent. So if benzene is present in an organic compound as a substituent, then those benzenes are known as phenyl groups. Okay, those benzenes are known as phenyl groups. So we use the term phenyl when naming those compounds. So in this case, in the second example, as you can see, you have a heptane carbon chain as your primary carbon chain because it is the longest, it has the most carbon. So this will be the primary carbon chain, and benzene is going to be your substituent, and it is attached to the second carbon. So you have a phenyl group on the second carbon, so it will be 2 phenyl heptane. Okay, heptane. All right, so keep that in mind. You might have to use the benzene group as a secondary group or a substituent if the other carbon chain is longer than, or other carbon chain has more carbons than benzene. Okay, sometimes you might have substituents where benzene group is attached to a CH2 group, and then this is attached to a hydrocarbon chain. So this whole thing will be a substituent, right? This whole thing, the benzene ring and the CH2 will be a substituent. So the name of this substituent is known as the benzyl group. Okay, so benzyl and phenyl are different. Okay, phenyl only has the benzene ring, so that will be your substituent. But benzyl groups, okay, benzyl groups have a benzene ring and a CH2 group. Benzyl group has a benzene ring and a CH2 group. Keep those names, remember those two differences. Okay, so when you have more than one substituent on benzene, or let's say you could have a di or tri or tetra substituted benzenes, right? So when you have more than one substituent, the nomenclature could be different. Okay, could be different. So if you only have two substituents, the nomenclature is somewhat different as compared to having, let's say, three substituents. So let's talk about these di-substituted benzenes where you only have two substitutions. As an example, in this benzene group, you have two chlorines as the substituent, right? So this is a di-substituted compound or di-substituted benzene. So when you are naming di-substituted benzenes, you are supposed to learn the locations of the benzene ring with respect to the primary substituent. So let's say this X right here is your primary substituent. Okay, so with respect to the primary substituent, okay, ortho position is the adjacent carbon. Okay, so any substituent you have in these ortho positions or the immediately next carbon, that location is called ortho. Okay, so if the next substitution is two carbons away, that location is known as meta. Okay, and then if the second substituent is directly opposite to the primary substituent, that location is known as para location. Okay, so this might be the first time that you are learning these names for benzene carbons with respect to a substituent. Okay, so if the substituent is directly next to the primary substituent carbon, then that location is known as ortho. Two carbons away, that location is known as meta, and the fourth carbon is known as para. Okay, so if you take a benzene ring, and let's say you have a primary substituent called X attached to a certain carbon, and number one carbon will always be the carbon that has the primary substituent, and then number 2 carbon and number 6 carbon are known as ortho. Okay, number 2 or number 6 is known as ortho. Okay, and number 3 and number 5 carbons are known as meta, and number 4 carbon in benzene is known as para. Okay, number 4 carbon in benzene is known as para. So I would recommend that you guys remember those names when naming di-substituted benzenes. So let's take our first example where you have two chlorine atoms. Okay, as you can see, both substitutions are equal. So let's pick one chlorine to be our primary substituent, and then as you can see, the other chlorine is present in the ortho position, right? Ortho position. So this compound has the name ortho. Okay, and of course it is a dichlorobenzene because you have two chlorines. So this is a dichlorobenzene, but the location of the chlorine is ortho. So the name will be ortho dichlorobenzene. Okay, ortho dichlorobenzene. So let's go to the next example. Okay, in here you have two CH3 groups as the substituents. Okay, two CH3 groups as the substituent. Let's take one substituent as the primary substituent, and then the second substituent is on the third carbon. If it is on the third carbon, that is meta position, right? That is meta position. So the name of this compound will be a dimethyl benzene, because you have two methyl groups. So this will be a dimethyl benzene, but the location of the second substituent is in a meta position. So the name will be meta dimethyl benzene. The name will be meta dimethyl benzene. So third example is actually kind of interesting, so you might want to pay more attention to it. Okay, in here, of course, the primary substituent is the aldehyde group. Okay, the aldehyde group. Why did I say that? Because that is a non-systematic compound. Whenever you have a benzene directly attached to an aldehyde functional group. Okay, so the non-systematic name for this compound is known as benzaldehyde. So obviously you have a benzaldehyde in here, and it also has a substituent. In here. The substituent is present in the para carbon, fourth carbon, or the para carbon. So the name of this compound will be chlorobenzaldehyde, but the location of chlorine is para, right? So the compound name will be para chlorobenzaldehyde. Okay, and then in this last example, you have a toluene, and it is reacting with bromine to give you a brominated benzene ring. Okay, so you already know that this compound is a toluene, right? You already know that this is known as toluene. And then bromine is present in the fourth carbon. Okay, it is on the fourth carbon, which we call para carbon, right? So the name of this compound will be a bromotoluene, but the location of the bromine is para, so the complete name will be para bromotoluene. Okay, sometimes we use the whole name, but obviously to save time and space, you can easily use the abbreviation. So for ortho you can use O, for meta you can use M, or for para you can use P. Okay, so that is how you name di-substituted benzenes. The thing to remember is that if you have a non-systematic name, or if you have a compound that contains a non-systematic name, you might have to be a little bit careful. Okay, all right, so next up we are going to talk about benzenes with more than two substituents. When you have benzenes with more than two substituents, what we do is we will identify the primary substituent. Okay, and then once we know the primary substituent, we will start numbering the benzene ring by giving number 1 to the carbon that contains the primary substituent. We will start numbering the benzene ring by giving number 1 to the carbon that contains the primary substituent. Okay, so after that you will try to give lowest possible numbers to your substituents. That is why you are going clockwise and not counterclockwise. If you go counterclockwise, the first substituent that you are going to see is on the third carbon, but if you go clockwise, you are going to see a substituent on the second carbon. So you will try to give lowest possible numbers to your remaining substituents. Okay, all right, so here are some examples. Okay, so in here our primary substituent will be one of the two CH3 groups. Okay, we will take this CH3 group as the primary substituent. Why? Because it will give lowest possible numbers to other substituents. Okay, if you take this one, then you will not give lowest possible numbers to the other two remaining substituents. So that is why we are giving this. You can try the other way around if you want to. Okay, so you have a benzene with two methyl groups, so it's a dimethyl benzene, and a bromo group. Okay, so this will be 4-bromo because bromine is on the fourth carbon, and then also you have a dimethyl, but the methyl groups are on 1 and 2 carbon, so it is a 1,2 dimethyl benzene. In the second example, you have a phenol. Okay, Okay, when it comes to phenols, that is your primary aromatic compound, and it has two substituents. When you number the substituents by giving lowest possible numbers, you have a 2-methyl group and a 5-methyl group, right? So this will be 2,5-dimethyl phenol. Okay, 2,5-dimethyl phenol. So I'm not going to teach you all the primary nomenclature rules that we learned before. Okay, so I'm guessing that you guys are comfortable with all the nomenclature rules that we learned in earlier chapters. Okay, and in here you have a toluene. Okay, this right here is your toluene. Okay, and then in this toluene you have 3 nitro groups on carbon number 2, carbon number 4, and carbon number 6. So it will be a trinitrotoluene, and the locations will be 2, 4, 6. Okay, so this will be 2, 4, 6 trinitrotoluene, or commonly known as TNT. Okay, commonly known as TNT. Alright, in your lecture note, the next slide is a worked example. So what I want you to do is I want you to pause the video now and see if you could name this compound without my help. See if you could pause the video and then do this compound without my help. Alright, so in this benzene, in this aromatic compound, of course you have 3 substituents. You have 3 substituents. You have an ethyl group, and then you have 2 nitro groups. Okay, you have 2 nitro groups. So when you're naming these, you have to try to give lowest possible numbers to your substituent. So ethyl group will be number 1. So this carbon will be number 1. This will be number 2, 3, number 4, number 5, number 6. So you have a 1 ethyl group, and then you have a nitro group on second carbon, and you have another nitro group on fourth carbon. So you will start according to alphabetical order. So you have a 1 ethyl, 2, 4 dinitro benzene. Oops, sorry. 2,4-dinitro benzene. Okay, this will be your name. This will be the name of your compound. One ethyl 2,4-dinitrobenzene. Right guys, with that example I'm going to conclude this lesson or this video. If you have any questions, please come and talk to me, and you will have plenty of examples to work with in your quizzes. So let me know if you have any questions. Okay, you guys have a good one. Take care.